How to set AVS to protect our inverter from under voltage and over voltage. Remember, we are living in a country whereby most of the current we have from our grid supplies around 130, 140, 150. If there are some area that they have as low as 80 something volt. Now, if you don't want it to enter into your inverter during installation, you get this AVS. Once you get the AVS, you use it to protect the over voltage or under voltage to your inverter. Now, how do you set them? Let's take the first thing you need to check you have to check your inverter. What is the maximum voltage your inverter can handle? That is the input voltage. What is the maximum input voltage your inverter can handle? You check the manual. Also, what is the minimum voltage recommended for your inverter? Once you know the two, then that's what you are going to use to set this AVS. You don't just set AVS offered. What you need to do, because different inverter has different voltage value. All inverter are not the same. So different inverter, you check the inverter you are working with. If the maximum voltage can handle is 240, you set this AVS at 240. If the minimum voltage it can handle is 180, you set it as 180. If it is 170, you set it as 170. If it is 200, you set it as 200. So it will not get damaged. So once you check that, once you know the minimum voltage and you know the maximum voltage, input voltage, that is the life and neutral. Once you know the maximum voltage you can handle, then you will be able to set this AVS. Now I have my bulb here, I have my iron here that I'm using as the experiment, and I have my AVS and my breaker. Now this is my power source connected to the AVS. I have the in here. You can see the in. This is the in here, the live here, and the neutral. The out here. You can see the out, the live here, the neutral. Then I supply it to my breaker, from my breaker to my load. Now, how do I set it? Once you understand the parameters of this AVS, you go straight to them. Now, on this AVS, P1 is this time it will take this AVS to supply current house. P2 is the recovery time. That is when this AVS senses any error, before it regain back to its normal state, it will take 30 seconds. You can set it as well. You can increase it and you can decrease it. Now this P3 is our over voltage. According to the manufacturer, what is set there already is this 270. Now, if I check my inverter and I notice that my inverter can only handle, let's say 250 or 260, I will go to this number 3. Then I will reduce it back to what my inverter can handle, or a little bit lesser. Let's say my inverter can handle 270 volt maximum, 270 volt, or 280 volt, or 260 volt, or 240 volt. I can reduce like 5. Let's say, for example, my inverter can only handle 240. Now what I need to set is, I will set 230 on this, so that to protect it more. Sorry, I'm going to go to P3. Now P3, you reduce it. Press it down to 235. I want to set it as 235. This 235 means that whenever the voltage is more than 235, this AVS to cut power, should not supply to my inverter. That's the meaning. Whenever it is 235, but on the screen here you can see that it is 220. Now whenever it is more than this 220 and it's up to 235, it will not supply out. That's the meaning. Now if I want to set under voltage as well, that is whenever this voltage, which is 220 here, is below what my inverter can handle, then this AVS will cut off power as well. Now you go to this pivot is recovery voltage. The recovery voltage, because the other one is 270, the recovery voltage is 265 here, but I'm going to reduce it to 230 because I've already reduced the what's it called, the over voltage to 235. So the recovery voltage must be below the over voltage. The recovery voltage must be below over voltage. So I'm going to reduce this to 230, sorry, to 230. I want to reduce it to 230. I will explain. 230. That is, what this 230 means is that once the power source, once the voltage from the power source is 235, this will cover cut off power. Now, before it can now supply power back to the inverter, the voltage must be around 230. That's what that P4 means. That is, the voltage, the recovery voltage means it must be around that range. That is, from 230 below, it must be that 230 below. That's what I said there. Remember, I said I've set the voltage, over voltage to be 235. Now, 235 means that once the input voltage, which is this 220, once it gets to 235, this AVS will cut off power. Immediately it cut off power. Before it can supply power back to the inverter, the voltage must be around 230. It must be around 230 or below 230. That's what this P4 means. This P4, that's what it means. Now, this is P5, which is 170, means under voltage. It is under voltage. Under voltage means that, okay, your power source, let's say you are living in an area whereby your power source from your NEPA or from your grid is always low voltage. Now, low voltage means maybe you are having around 135, around 140, or around 150. And you don't want it to damage your inverter, because some inverter will be showing error, some inverter will not accept it. Like, if you are using Felicity inverter, once the voltage is below, let's say around 170 or 160 thereabout, the inverter will be showing error. It will be showing error. But if you are using some other inverter, if you are using like TechFine inverter will not accept it at all. It will not accept it. You'll be seeing the voltage on the screen, but it will not accept it at all. It will not change. But for Felicity will accept it, but it will be showing error. So for you not to be seeing that error, you have to have this to set the voltage. Now you go to your P5. You want to use this AVS to set the low voltage. The low voltage. You go to this P5. Once you go to this P5, you can increase it and you can decrease it. Once you know your inverter, if your inverter can only handle 180 or 200, you set it. You go to this P5. Then you can increase it to 180 or 200 or 190 or 195, as the case may be, as far as you want it, as far as your inverter can handle it. Now, if you set it as 180, this 180 means now is that if your voltage, the voltage from your NEPA source or from your grid source must always be 180 before it can supply to your inverter. If it is not 180, this inverter will just be blinking here. The value will just be blinking here. You will see this green light. It will just be blinking. You won't see the green light. So that's what we said there. Now, the recovery mode for the low voltage here is 175. 175 is because the reason why it is because 175 is because, remember, it was set as 170 before. So I increased it to 180. Now I must also increase the recovery voltage as well to, let's say, 185. Reason because, remember, at 180, this inverter have sensed error that, okay, the voltage that is coming is 180. So it has already cut off power. Now, for it to now regain back to supply outside, it must be above that 180. So 180, if I set it as 185, that 185 means that once the voltage is now around 185, the AVS will now supply power back to the inverter. It will supply power back to your inverter. It will supply back to your inverter. So this 175, I'm going to change it to 180. I want to change it to 185. 185 means that once it senses low voltage at 180, then until the voltage now gets back to around 185 before it can supply outside. That's how to set your voltage, your over voltage and under voltage, to protect your inverter. Now let's do a practical example and see how effective these things work. Now what I want to do is that this is the 220 volt that is coming from my source, 220. I want to reduce it. I want to take this as over voltage. So I want to see how this work for over voltage. I want to reduce this as over voltage. Once I reduce the over voltage inside this AVS, then it will cut off power to these two bulb, to this bulb and to this iron. Now I've switched on the bulb and iron. You can see the iron has come up. This will come up now as well. So I've switched them on. The iron has come up. Now I want to set, you can see it has read the current that the iron is demanding, which is 1.5 amps. Now this 1.5 amps means that this 220, I want to reduce the voltage of this 220 so that, wait, let's check something. It's like this thing have affected my bubble. Don't worry. Now I want to set the voltage. I want to see how over voltage work. This is a 220 volt. I want to reduce the voltage so that once it reduces the voltage, I want to take this as over voltage. Once I reduce the voltage, let's see how this thing works. Now I'm going to go to my P5, which is, no, sorry. I'm going to go to my P3. P3 is over voltage, which we have already set around 235. Now 235 means that I want to reduce it to let's say 200, and see if this will supply power outside. If you reduce this to 200, let's reduce this to 200 and see what happens. Now I've reduced it to 200. Now let's see. You can see that it's blinking over voltage. It's not supplying outside. That is because I've reduced the voltage to 200. Sorry, I've reduced the voltage to 200. So now the 220 that is coming in from my source is taking it as over voltage. The AVS is taking it as over voltage. That is the reason why it's blinking. So I'm using it, I'm testing the effectiveness of this AVS, if it will work for me or not. So I reduced the over voltage to 200. That is, when the voltage is more than 200, this AVS should not supply current outside, should not supply outside. So that's what it means there. And the voltage that is coming in is 220. That is the reason why it's blinking, because it has taken the 220 as over voltage. So if I increase it back to maybe my 230 or to my 235, you can see that this blinking will stop and it will give out output effectively. Let's go to P3, which is 200. Let's increase it back to maybe 235, and let's see how it works. You can see it counting down. Because I've increased it, it has sensed it counting down. Is the time, the 30 seconds that we have already set as recovery time is what is reading, counting down now. Let's see how it will supply to the let's see how it will supply to the iron. You can see it has supplied to the iron. You can see it has supplied to the iron. That's because the voltage is normal now, because we have already increased the voltage, the over voltage, to 235. That's how it works. Thank you for watching. Thank you for listening. Don't forget to like, share, and comment.